cosine theta 1 times cosine theta 2 minus sine theta 1 times sine theta 2. What is this? Which identity should I use? Sine or cosine? Cosine. Cosine of what? Cosine of what? Don't just forget what you have learned, right? It should be the theta 1 plus theta 2 is the cosine of a sum, right? So that means this part plus this part, you have the cosine of the theta 1 plus theta 2. Now let's look at this imaginary part. We have the sine theta 1 times cosine theta 2. And plus this sine theta 2 times cosine theta 1. Let me put this cosine theta 1 first. And then sine theta 2. Now what is this? Sine of theta 1 plus theta 2, right? So this is a sine of a sum. Okay. So we just use these two identities right, and to here. Now, the second part is the I times sine of theta 1 plus theta 2. So that means when you multiply two complex numbers in the trigonometric form, you just need to multiply their moduli, right, the R1 and R2, and then add the arguments. So the argument of the product is equal to the sum of the arguments of these two complex numbers. Let me rewrite this result in the next page. So now you have the Z1 times Z2 is equal to R1 times R2, then times cosine of the theta 1 plus theta 2, and plus I times sine of theta 1 plus theta 2. Now, let's continue to deal with the quotient. So Z1 divided by Z2. You have the R1 times cosine theta 1 plus I times sine theta 1 over R2 cosine theta 2 plus I times sine theta 2. We know when we divide two complex numbers, we need to multiply both the numerator and denominator by the conjugate of the denominator. So now let's multiply the conjugate of this denominator. We have the cosine theta 2 minus I times sine theta 2. And then here we also have the cosine theta 2 minus I times sine theta 2. Now let's simplify. R1 over R2. The product of these two parts. So we have the cosine theta 1 times cosine theta 2 minus I times cosine theta 1, and then times sine theta 2. And then plus I times sine theta 1 times cosine theta 2. And then minus I times I square times sine theta 1 times sine theta 2. So you have the minus I square times sine theta 1 and sine theta 2. Now for the denominator, you have the cosine theta 2 plus I times sine theta 2 times the cosine theta 2 minus I times sine theta 2. So actually we have this formula, right? We have the A plus B times A minus B equal to A squared minus B squared, right? So now you can get the cosine square theta 2 and then minus the square of the I times sine theta 2. So that is I square times sine square theta 2. Now let's simplify. So let's first deal with the denominator. So this guy is equal to cosine square theta 2 plus, because the I square is equal to negative 1, right? So negative, negative, you have the positive, plus sine square theta 2. Then for the numerator, so we combine this guy with this guy. So I square is equal to negative 1. So negative, negative, you have the positive. So for these two terms, you have the cosine theta 1 times cosine theta 2 plus sine theta 1 plus sine theta 2. Let me write this right here. So you have the cosine theta 1 times cosine theta 2 plus sine theta 1 times sine theta 2. What is this? Cosine of the theta 1 minus theta 2, right? So we have the cosine of the theta 1 minus theta 2. So we get this real part for this numerator, cosine of theta 1 minus theta 2. Now let's look at the imaginary part. Imaginary part, we have the sine theta 1 times cosine theta 2 minus cosine theta 1 times sine theta 2. And we know this is just the sign of difference, right? So it's equal to sine of theta 1 minus theta 2. So now the imaginary part is just I times sine of theta 1 minus theta 2. And this is the 1 by the fundamental identity. So finally, we got R1 over R2 and then times cosine of the theta 1 minus theta 2 and plus I times sine of theta 1 minus theta 2. Then done. So by now, we have found the formula for the product and quotient of two complex numbers in the trigonometric form. Any question?